Let's talk about thread blocks and why they're there. Hopefully you have some questions about how the GPU works, since we've just sort of been telling you about threads and thread blocks without giving you much motivation. So you might be wondering, why do we divide the problem into blocks? When do blocks get run? And if you have a whole bunch of thread blocks, in what order do they run? And I've told you that thread blocks were about letting groups of threads cooperate, but I haven't told you how those threads cooperate or with what limitations. To answer this, we're going to have to dive in to learn a little bit more about the GPU hardware. At a high level, a CUDA GPU is a bunch of these. We call them streaming multiprocessors, or SMs for short. Now, different GPUs have a different number of SMs. So a small GPU might only have one SM, whereas a really big GPU might have 16 SMs, for example. And an SM, in turn, has many simple processors that can run a bunch of parallel threads. It also has some other things like some memory that we'll talk more about in a moment. So when you've got a CUDA program with a bunch of threads organized into thread blocks, the important thing to understand is that the GPU is responsible for allocating blocks to SMs. Let me say that again because it's really important. The GPU is responsible for allocating the blocks to the SMs. So as the programmer, all you have to worry about is giving the GPU a big pile of thread blocks, and the GPU will take care of assigning them to run on the hardware SMs. All the SMs run in parallel and independently.